Hi, welcome back. So we are at the section to discuss now how to technically actually work on creating arrays and different type of it using the NumPy package. Now basically all what you need to do to create a simple array is to pass a list as we have illustrated earlier. Also you might want to create something called the zeros vector, and that's as simple as zeros function. And basically zeros function asks you an integer as an argument to specify how many zeros you want to create for this vector. Print the z, you get the result as you might expect, and that is a vector of 4 zeros. The same thing with another function called the ones, and run it one more time, you will get ones of vector. Also you might want to create an empty array just like that, return for you a vector with values in it with zeros, which is considered to be an empty. You might want to arrange actually, and then you will get a vector with 0, 1, 2, 3 as 4 values or 4 elements has been assigned here. If you would like to also work on the arrange much more, you might decide start of the arrangement, the end, the steps. To run this, you will get 4 values from 2 to 9. 9 won't be included, and by 2 steps. Also, you might want to run another one called the line space. Takes the start at the end, and then how many values you would like to run. Now, basically what it does, this line space, it creates an array with values that are spaced linearly in that interval you provide, which is from 0 to 10. You can explicitly actually specify which data type you want to use, and that is as simple as, for example, if I would come back to the MP here of Z and I will create ones, D type, for example, integer 64. If you would run this, once again you will get the values ones and ones. However, the T type of this one is integer 64. Next thing, maybe also you want to work on some adding, removing, and sorting elements in NumPy. Now, sorting an element is simple with something called np.sort. So sort function does this in ascending order, and that's by just getting np.sort. You will see the list has been just sorted in ascending order. Now, if you start with these arrays, let me give you an example. If you want to concatenate the np.concatenate function, and just it asks you, as you could see, to specify the arrays in a tuple which you would like to concatenate. Now, if you run this, you would get the result as expected by concatenating the values of both of them. Maybe I want adjust this one to be maybe 2-dimensional with 3 and 4. After concatenating the A and B, I'm going to decide on which axes I'm going to do the concatenation. Now they have 2 axes, on the 0 axis, on the 1 axis. So if I would have to run now this, I will get the result as expected, which is returning 3 by 2 by concatenating on the axis of 0. Now you might wonder, if we change this to axis of 1, what the result would look like. Let's run this one and we get into a problem here. All the input array dimensions for the concatenations must match exactly, but along the dimension of 0, which is the first one, the array at index 0 has size of 2 and the other one has size of 1. So here, to address the problem, we need to get back here and add a new dimension. So if I would have to run this one, is going to work fine. 2 by 4. So axis of 1, it works as a column wise. However, the axis of 0, it works as a row wise. Now, next thing maybe we want to check is, how can we check the shape of the array? Now, here are the opening of the tensors. Now, this is my first matrix, this is my second matrix, and this is my third matrix. All of them are inside this bracket down here. To find out what is the dimension of this array, the ndim, which is returning the number of dimension. This is the built-in variables. I will get is a 3, which basically we knew is a tensor of 3, right? Now, if I would have to see something called the size, let's try to run this size of this tensor. and see with the result 18 as expected. Also, you might want to find the shape. When you run it, is returned like this. So you have to imagine and visualize. Now, one of these three indicating the total number of matrices inside the tensor, and one of the other trees indicating the number of variables for each matrix. Now, to figure that out, what I'm going to do basically, just simply, maybe I would create a new matrix here. So we got tensor with 4. So the first digit in this tuple indicate how many matrices we have. Then the other are indicating the size or the dimension of each matrix, which is 2 by 3. Now, last on this section, maybe you might want to ask a question. Can you reshape an array? The answer is yes, and that is as simple as using the function reshape. Now, I'm going to just use the reshape function, and it expects a tuple with 2 arguments. How many rows? How many columns? So, for example, if I would have to make it 3 by 2, so you could see here. However, if I would have to exceed the number of elements inside, that I might run into an error. So you have to understand the total number of multiplication of those arguments must equal to the number of values that you are passing on. So what we got here, we got A to be shaped, then ask you what is the new shape you would like to do. I would like the shape to be 1 row by the number of element of 6. I mean, I get like 6 dimensions here. Now, next actually we're going to talk about is how to convert 1 dimension into 2 dimension array and how to add a new axis to that array. That's exactly what we're going to do next. I'll see you then.